This video will discuss how to simplify radicals that have index higher than 3. So let's start with some vocabulary. So first of all, this symbol right here, and feel free to pause the video so you can copy the words that go in the blanks, but this symbol right here is called the radical symbol. So all of these are radicals on your page. Then the little number that's right here, so the 4 in this case, it is called the index. So if it doesn't have a number there, so for example, if I asked you this, and there is no number there, it is a 2. So the index here is 2. So when the index is a 2, we call this a square root of 16. When the index is a 3, we call this the cube root of 16. So when the index is higher than 3, this is red, the 4th root of 16. But this is a radical. Now the number that's in the inside, so the 16, that is called the radicand. So the number inside the radical, instead of me having to say the number inside the radical, the short way would be to say the radicand. Okay. So we talked about in the first video of this lesson that if I had the square root of -4, that the index here is 2, which 2 is an even number. And we talked about when it was a 2 that this was not possible because 2 times 2 is 4. And -2 times -2 is also 4. So it doesn't work. So when the index is even, so 2, 4, 6, 8, etc. So this little number right here, when it's even, you can't have a negative inside the radical symbol to get a real answer. So at the end of this chapter, we'll talk about imaginary numbers and working in the complex number system. But you can see our directions say we're working with real numbers. So we don't want a negative inside the radical when the index is even. So if we take a look at example 10, we're fine. Because this is odd, this is an odd number, it is okay to have a negative inside the radical. So this is saying what times itself 5 times would make 243. So if you're not sure, if you don't have a calculator, you would guess. So let's try -3. Let's see if -3 would work. So we know it's negative since the index is odd. And if we didn't have a calculator, let's check. So -3 times -3, that's 9. Another -3 times -3 is another 9. And then 9 times 9 is 81. And 81 times negative, that would be negative, so that's why it works. And then 81 times 3 is 243. So that's how I know we would get -3. Then we talked about in a previous video that you take the index and you divide it into the exponent of the variable. So we would do 5 divided by 10 is 2. So that's why the answer would be -3x squared. So again, if we multiplied all of this together, it would equal -243x to the 10th. That's why this is the answer. Okay, let's check out this one here. This is saying the 6th root of x to the 6th times y to the 12th. So since there's variables in here, we're just going to divide. So this is saying what times itself 6 times would make this. So the trick is when you have variables is you just divide how many times the index goes into the exponent. So 6 goes into 6 one time. So we're going to have just, our answer is just going to have a 1 on the as the exponent for the x. And then we're going to divide 6 into 12, and we would get 2. So that's how we know that the answer is xy squared. because if we multiply all of this together, we would get the Radicand value. Okay, let's go ahead and take a look at number 12. So this says, what times itself 4 times, so 1, 2, 3, 4. What times itself 4 times is negative 81. So if we try negative 3, we would get 9 and 9 and 9. It doesn't work. We can't have this be a negative and this be even. Can't. So our answer would be not a real number. So you don't want to write not possible. The proper way to address it is not a real number, because it is possible if we're working in the complex number system. So that's why we're going to write it's not a real number. Alright, let's take a look at number 13. So this is saying what times itself 3, 4, 5, 6, 7. 7 times, and it only makes 128. So right off the bat, I'm going to go ahead and guess 2, because 7 of them would only make this small number. That's why I think it's 2. So again, you would check, multiply, would do 2 at a time, and then multiply all of them together in any order you want. And this is how you would do it if you didn't have a calculator. And it would work, so we would know it's 2. And again, if you had a calculator, you would enter this in as, this is the 7th root of 128. So we would type in 7, and then second, and the button with the x and the radical, and then 128. And we would get 2. Okay, now as far as the exponents go, we're going to go ahead and divide. So 7 into 14, that's twice. And then 7 into 7, that's 1. So if you're wondering, what if it doesn't go in evenly and you had a remainder, that's what we're going to talk about in section 8.3. So we're going to talk about what we call irrational radicals. We're going to talk about it in the next video, but we're going to learn how to simplify those in section 8.3. Okay, so when the value that is in the radical is not a perfect square, all we can do is simplify them or estimate them. So when the number in the radical is something like this, square root of 5, this is saying what times itself is 5. And it's not a perfect square. So what we call this is an irrational number. So an irrational number is it's going to be a decimal, and it does not repeat, so none of the values repeat, or it doesn't end. So kind of like pi, if you've heard of pi before, 3.14159, it has all those numbers, none of them repeat, and all we can do is we can approximate these or leave it in the radical as it is, in a simplified way that we'll learn in 8.3. So if I put this in my calculator, what times itself is 5? Again, this is an irrational number. There's all those decimals. So it's a decimal. It doesn't end. There's a lot more numbers, but the calculator screen can't fit it, and none of these numbers are repeating. So again, we call this an irrational number. When the number inside the radical, you can't answer perfectly. So if I ask, if you got the answer of square root of 5, this is called the exact answer when it's in the radical. And then if you put it in your calculator and you get that decimal, the decimal part, so if we were rounding, let's say, to the 100th place, that would mean 2 decimal places. We'd have to go to the 6, which is 5. Or higher, so we're going to round up, and it's about 2.24. So this is the exact answer, this is the approximate answer. So let's go ahead and practice using a calculator, approximate, round your answers to 2 decimal places. Instead of saying that, I could have said 100th place. So this is saying what times itself is 24. Well, if I don't use a calculator, I know that 5 times 5 is 25. This is very close to 25. So I know this answer should be 4 point, probably 8 or 9. It should be really close to 5, the answer to this. So let's use our calculator and do the square root of 24. So again, the calculator is figuring out what times itself is 24. And it says to round to 2 decimal places. So the calculator has all these numbers on the calculator screen, right? And it says round to 2 decimal places. So we have to go to the third number. You always go one more than what it wants. And if this is 5 or higher, which it is, the 89 is going to become 90. One more. You're going to add one more to that. Okay, so you do want to put that 0 there because it says 2 decimals. If you don't put that 0 there, then it doesn't have 2 decimals. Okay, now this is saying what times itself 3 times is 12. So I'm going to type in the 3 and then the X in the radical button, 12. So what times itself 3 times is 12? Well, I know that 2 times 2 times 2 is 8. And I know that 3 times 3 times 3 is 27. So this value here is going to be more than 2. It's like right in between 2 and 3. So it's going to be 2 point something. So it's about, so again, it has 2.2894, etc. It has all those numbers. But it says to round to 2 decimal places. So we go to the third number, and because it's 5 or higher, the 28 is going to become 29. Okay, so again, these are called irrational radicals because you can't just look at it and these don't have a perfect answer. So if we take a look at the example, square root of 16 versus the square root of 8. This one is irrational, whereas this one is rational. So that's the difference. It's called irrational when the number inside the radical, what times itself is 8, you can't do that. There is no perfect answer. But because the answer to this is 4, we call it rational. Okay, so if I go put a to the 4th here, it's still rational because 2 can go into 4. If I were to make it square root of 16 a cubed, now it's irrational. Because even though this is rational, 2 can't go into 3. So we're going to do problems like these two, the ones that are irrational. In section 8.3, we're going to learn how to simplify them. And this video stuck with problems that we could. They were all perfect squares or perfect cubes.